Welcome back to our channel. In today's video, we have the pleasure to present to you the diaphragm cell. Now take note that diaphragm cell is one of the three cells that we use to synthesize very important chemicals in chemistry. These chemicals include sodium hydroxide, hydrogen, and chlorine. Now, diaphragm cell is the third cell that synthesizes these chemicals in addition to the mercury cell and the membrane cell. Now, we did special videos for these two other cells, and those of us who didn't get an opportunity to review them with us can have the chance to do so. So for mercury cell, check it out here, and for the membrane cell, we have a special video here. Thank you as you get to learn more about those other two cells in the prescribed videos. Once we are through with the review of the cell, we shall have a look at 2004 Chemistry Paper 2 for the Kenya Certificate of Secondary Education, question number 7, which tested the understanding of the diaphragm cell. Before we do that, let's begin with the one raw material that we need for the cell. So this is a cell that needs only one raw material, and that is brine. Now, brine remains concentrated sodium chloride solution. The raw material will get in from the left compartment at the anode side. Now, let's talk about the anode now. And as you can see, the anode is on the left-hand side here, and it is made of titanium, just as been labeled here. Though we have other materials that you can use, which includes graphite or even platinum. So before we move to the cathode, let's mention that our brine has got 4 ions. We have chloride ion, we have got sodium ions. These are directly from the salt that we use to make the solution. Though, because of presence of water, there will also be hydroxyl ions that will be there together with hydrogen ions. So at the anode, we shall discharge chloride ions, and this is because of their higher concentration as compared to what is normally discharged ordinarily, and that is hydroxyl ions. So when you discharge chloride ions, we will have 2 moles of them aqueous being discharged to give 1 mole of chlorine, and this is usually accompanied by 2 moles of electrons. So once this reaction has taken place, chlorine now will leave through this hood on the left compartment. Now, between the anode and cathode, we have got a porous diaphragm here, which we are going to explain the use in a moment. But first, let's have a look at cathode. Now, cathode as we can clearly see here, is made of steel. At cathode, we shall discharge the usual hydrogen ion. 2 moles of our hydrogen ions will accept 2 moles of electrons to give us hydrogen gas. The hydrogen now will leave through this other hood on the right compartment of the cell. So let's now get back to our diaphragm. The diaphragm has 2 functions. Number 1, it will prevent sodium hydroxide, which we are producing here as substance U, from mixing with chlorine. If these 2 substances mix, we shall produce what we call sodium hypochlorite, which we do not need now, though it is also a very important substance used as a bleaching agent. Number 2, the diaphragm also allows for movement of ions. Actually, it allows for movement of solution from the anode side to the cathode side. And it is made possible due to the differences in the levels. Candidate, you can see the level on the left is higher than that on the right. So this ensures that at all times our solution is able to flow from anode to cathode. So now let's look at how we are able to produce sodium hydroxide. So on this side, we discharge chloride ions and we leave mostly sodium ions in the solution that now permeates through our diaphragm. There is a lot of sodium ions that are there. On this other side, we discharge hydrogen ions. So mostly we leave hydroxyl ions in the solution on this side. So once the movement has been made possible, now sodium ions are now able to mix or rather react with hydroxyl ions, and we are able to form sodium hydroxide. This is what leaves as substance U. But we want to mention here that this cell has one main disadvantage, and that is most of the sodium chloride remain unchanged. Actually, what comes out of here is a mixture of sodium chloride and sodium hydroxide, and therefore we can call it caustic brine. Caustic brine. So to be able to concentrate our sodium hydroxide from it, we normally do evaporation so that we're able to minimize the percentage of the impurity of unchanged sodium chloride in our sodium hydroxide. And with that, we have completely reviewed the working of the cell together with its components, the anode, cathode, and the diaphragm, including the 2 functions of the diaphragm. So we now get back to the year 2004 and we remind ourselves of what the examiner expected as correct responses to the questions. So we begin with part A, where we were told that brine usually contains soluble calcium and magnesium salts. So you are expected to explain how we can use sodium carbonate to purify the brine. Now, the correct response here would have been that we begin by adding sodium carbonate. I will use symbols to save on space. So we add sodium carbonate to our brine, and the reason of doing this is to precipitate the calcium and magnesium salts. So they will be turned into solids which are precipitates in form of carbonates. After we've done that, the next thing that we do is to filter, and we are filtering to remove the precipitated calcium and magnesium salts so that we are able to obtain purified brine. That would be the expected response for part A. For part B, the examiner informed us that the diagram below represents a diaphragm cell that is used to electrolyze pure brine, of course after purification in stage A or in part A, where we use sodium carbonate. So we've gone through the cell. We do not have to do that again. So we now proceed to answer the questions that were based on the diagram. Roman 1, write the equation for the reaction that takes place at cathode. At cathode, we discharge hydrogen ions. So 2 moles of hydrogen ions in aqueous state would accept 2 moles of electrons, and we end up forming or producing hydrogen gas. At anode, we discharge chloride ions, and we have 2 moles of chloride ions being discharged or being converted into atoms to give chlorine gas, and the reaction is accompanied by loss of 2 moles of electrons. Next question, Roman 2, asked us to name the product that comes out at U, and we had agreed earlier that this is our sodium hydroxide, although it is contaminated so much by unchanged sodium chloride. Now next, we were to mention another material that can be used on the anode instead of titanium. Rightfully discussed, we talked of either graphite or platinum. The impurity that is present in the product U is obviously what we called unchanged sodium chloride, or just sodium chloride. 2 functions of the diaphragm was the next task for candidates in the year 2004. And the first function is to prevent mixing of chlorine with our sodium hydroxide. We've just mentioned that we would actually produce a bleaching agent, which is not the main reason as to why we are here. Number 2 is to allow movement of ions, specifically sodium ions that are moved from the left compartment to the right one. Lastly, candidates were asked to give one industrial use of sodium hydroxide, and we have quite a number. There is manufacture of drugs. Sodium hydroxide is also used in the manufacture of soaps. We have manufacture of detergents as well. Detergents, here we are talking about the soapless ones. And we also have manufacture of bleaches or bleaching agents. Anyone would score for that section. And on that note, we've come to the end of our short video where we have reviewed the diaphragm cell and its testing in the year 2004. Chemistry Paper 1, question number 7. Thank you so much for your company. Kindly subscribe, share, and most importantly, keep it right here for more of such really insightful reviews of chemistry.